Now we will consider another problem. Okay, this problem axis parallel to both HP and VP. Okay, take down the problem. A triangular prism, base side 30 mm, axis height 60 mm, lies in the horizontal plane on one of its rectangular face. The axis of the solid is parallel to both HP and VP. Draw the projections. Right. Now we will observe the given solid and given data. Given solid is triangular prism. A triangular prism. Okay, that means both the end faces are equilateral triangles. Right. Now, base side or end side is 30 mm. Right. And the axis length 60 mm. Okay, axis length 60 mm. Right. And axis, it lies in the horizontal plane on one of its rectangular face. Okay, and axis is parallel to both HP and VP. Now lies in the HP on rectangular face. That is the first one. The second position is given axis parallel to both HP and VP. Right. Now imagine the solid position. Here I don't have triangular prisms. That is the reason. Just imagine this. This is a triangular prism. And this end face is a triangle, equilateral triangle. This is also equilateral. Assume like that, okay? It is in a rectangle. Assume that this is a triangle. This end face is triangle. This is end face is triangle, right? And this is this face, obviously rectangular face. And this face, okay, if you remove like this, if you cut like this along the triangular edge, it is a rectangle. Okay, it is also a rectangle. It lies in the HP like this, right? Okay, it lies in the HP, horizontal plane like this. So now, the axis of the triangular prism parallel to both VP and HP, right? Okay, this is the position. Now, you tell me in which view we can see its true dimensions. Suppose if you see the front view, axis true dimension is visible. If you see the top view, axis true dimension is visible, and the true dimensions of end face in both front and top views not visible. But in the side view, if you see like this, then we can see its end face true dimensions, right? Therefore, the student need to start the side view first, right? Now we will start from side view. This is the reference line, and for the side view, one more reference line we need to draw. Let it be x1, y1. This is an auxiliary reference line, right? Now, it lies in the horizontal plane. When it is lies in the horizontal plane on its rectangular face, that face in the front view coincide with the reference line, and this plane we need to assume like this. In the side view, that face is coincides with the reference line. Therefore, by touching this reference line, we need to draw the respective equilateral triangle. Here, side end face side equal to 30 mm. Right. Now, by considering an included angle equal to 60 degrees. Okay, 60, 60, 60. Okay, let it be A, B, C. This is the side view, na? That is the reason I would like to give A double dash, B double dash, C double dash. Okay, and this equilateral triangle represents two faces, two end faces. Therefore, we need to give one double dash, two double dash, three double dash. Okay, likewise we need to give the numbering, and we need to give bracket also, because it is invisible. Right. Now, for the front view, we need to project it likewise. Right. In the front view, true length of the axis that is visible, right? And one end face we can assume here. Okay? Here you may ask, what is the distance from here? Actually, that is not given in the problem. For the side plane or profile plane, the plane which is perpendicular to both vertical and horizontal plane, that is called as profile plane. Okay? From the profile plane, that distance is not given in the problem. That is the reason any distance you can consider to represent one face. Okay, that face may be 1, 2, 3. Okay, therefore 1 dash, this is 2 dash comma 3 dash. That is over. Now, where is the axis? To locate the axis, you can consider angular bisector or angular bisector you can consider, and the intersection of these angular bisectors, this is the axis O comma O dash. Okay, this is side view O double dash. Right. Now project it. Right. Now, axis height we need to locate. Axis height equal to, or axis length equal to 60 mm. Therefore, long line dot, long line dot, long line dot, long line dot, long line. Likewise, we need to be right. Next, this edge is visible, and this length let it be 60. Therefore, other face. Okay, we can draw the axis beyond the object. Okay, right. Now give the respective numbering. This is A dash, this is B dash comma C dash. Right. Now we need to draw the top view. For the top view, project the front view like this. And here we need to project this A, B, C in the top view. Okay, these are need to be project like this. This one need to be project like this. Okay, to transfer the same distances here, we need to draw a 45 degrees line. This angle equal to 45. A 45 degrees line. After that, project it and project A and project 3 and C. Right. Now project it Now project this. And project it. Right? That means this is the projection from B and 2. This is the projection from C and 3. This is the projection from A and 1. Now we need to locate their respective points and we need to complete the diagram. This is from 1 and this is from 2 and B, and this is from 2 and 3. Therefore, this will be 2, right? And this will be B, right? Now, this will be 1, and this will be A, and this is 3, and this is C. Okay? This is C, right? Respective notation that is completed. You need to darken the visible edges. Okay? This 2B edge, if you see like this 2B is visible, and 3C, this is also visible. This is also visible, right? And 1A also visible, right? And end faces A, B, C, that end face, actually this face is not visible if you see like this, but the projection of AB here and AC here, okay? AB and AC both are visible, okay? Therefore, due to that projection, this end is continuous line and this end also a continuous line, right? Okay, this is the required front and top views. Front and top views. Here you observe that I am not returning the front view, top view like that. Actually, if you write it, that is good. Otherwise, after completion of the diagram, this is totally first angle projection. Therefore, you can draw the symbol of a first angle projection. Here, we need to darken this face also. This is a rectangular face. Okay, B, C, 2, 3. Okay, and this triangular prism is lies in the rectangular face in the HP. That is the reason 2, 3, C, B. You can see, right? Now we will consider one more problem. A tetrahedron side equal to 50 mm. A tetrahedron side equal to 50 mm lies in the HP on one of its face. The axis is perpendicular to HP and the face which lies in the HP, its one side is parallel to VP. One side is parallel to VP. Draw its projections. Now, tetrahedron. I think you know. Tetrahedron having how many faces? 4 faces. And the tetrahedron, all sides are equal and all sides are triangular shape. Right. Now, side length is equal to 50 mm. Okay, the axis height that is not given in the problem, but it is given. The solid tetrahedron lies in the HP on one of its face. Right. Next one. one side of that face, that means the face which is lies in the HP, is parallel to VP. Okay, one side of, I can call that as the base face. One side of the base face is parallel to VP. Parallel to VP. Okay, these two are enough to look at the position of the respective solid. Right. Now, assume that this is the tetrahedron. Actually, it is not a tetrahedron. This is a triangular pyramid. Okay. Assume that all the faces are equal. Right. Now that is a tetrahedron, and it is lies in the horizontal face on one of its face, and one side. Okay, you can imagine this side. This side is parallel to VP. Right. This position is correct, and this position also correct. Okay, this side is parallel to VP. Any position you can assume. Right. Now, which view we need to draw first? Top view. Right. Now, draw the XY reference line, and we need to draw a line parallel to reference line, because one of the base side, okay, is parallel to VP. Right. Construct equilateral triangle by considering 60 degrees included angle. Right. Now let it be A, B, C. Okay, and it is having lateral edges, and in the top view all lateral edges are looks like lines which are merged at the centroid. Okay, by considering angular bisector, you can draw the centroid, and right, these are the lateral edges which are looks like lines merged at the centroid. Let it be O. Right. Now we need to draw the respective front view. Project it upwards. Now I will project. When a base side ABC, if it is lies in the HP, the front view is coincides with the reference line. Okay. Therefore, up to the reference line I can project. This is A dash, B dash, and C dash. Okay. Now, what about axis height? See, axis height is not given in the problem. All sides are equal. That we know. Okay. Now, to find the axis height, one thing I can explain. Suppose if you see OA is inclined with VP, OC inclined with VP, OB inclined with VP. Okay. Suppose if you want, it's a true dimension, it need to be parallel to VP. Okay. Suppose if you consider like this, okay, all three sides are inclined with VP. No side gives the true length. Suppose if you consider this line is parallel to VP, then this line projection in the front view gives us true length. Okay. And one more thing we need to remember, the axis true length is visible in all the cases, this case and this case. Okay. And its true length is visible and it is perpendicular to the reference line. Right. Now, axis you can draw. Length we don't know. Long line, dot, long line, dot, long line. We can draw like this. Right. Now, OA, OA or OC or OB, okay, you can draw parallel line to reference line like this, and OA center, OA as radius, rotate it. What it indicates, now OA is, this is dash, A1 I can call. OA1 is parallel to VP. Okay, now if you project A1 here, this is A1 dash, okay, this is gives us the true length of OA. Okay, now we know the true length, OA true length equal to 50 mm. Therefore, with 50 mm radius, A1 dash as center, you need to draw an arc on the axis. Okay, this is also a constructional line. That is the reason I use this, right? Okay, right? Now this is the axis height, and this is O dash, right? Now you can draw the slanted edges. This is O C dash, this is O dash A dash, and this is O B dash. Okay, OB dash is overlaps on the axis. Okay, likewise you need to complete the respective figure, and this is also visible, and the base is coincides with the reference line. You need to darken, right? Okay, likewise this construction is important, right? With this, we complete the solids. Axis is perpendicular to either HP or VP. Axis parallel to both HP and VP. And from these drawings, we need to remember, when if axis is perpendicular to HP, that face of the solid is parallel to HP. Okay, therefore if it is parallel, in the top view we can see the true dimensions. Therefore we need to draw the top view first. Now another thing, when the axis is perpendicular to VP, respective face is parallel to VP. Therefore front view we need to draw first. Suppose axis is parallel to both HP and VP, in the side view we see the end face true dimensions. Therefore we need to draw the side view first. Okay, and